Hi, I'm Gary Stafford, a Principal Solutions Architect with AWS. You can find me on LinkedIn, GitHub, Medium, Twitter or X, and YouTube at Gary Stafford. Today's video demonstration is animation with Amazon Bedrock, creating generative AI video animations using Amazon Bedrock and Stable Diffusion XL 1.0. In this demonstration, we'll be using a Python-based Jupyter Notebook and the AWS SDK for Python, or Boto 3, to create generative AI-based images and simple video animations using Amazon Bedrock and Stability.ai's Stable Diffusion XL 1.0 foundation model. Amazon Bedrock is the fully managed service from AWS that offers a choice of high-performing foundation models, or FMs, from leading AI companies like AI 21 Labs, Anthropic, Cohere, Meta, Minstrel AI, Stability AI, and Amazon, all available through a single API call. Stable Diffusion XL, or SDXL, is the latest image generation model that is tailored towards more photorealistic outputs with more detailed imagery and composition compared to previous Stable Diffusion, or SD models, including Stable Diffusion 2.1. Stable Diffusion XL is a significant advancement in image generation capabilities, offering enhanced image composition and face generation that results in stunning visuals and realistic aesthetics. Let's jump into our Jupyter Notebook and begin our demonstration. I'll be using the latest version of Visual Studio Code as my IDE, and I've opened up my Jupyter Notebook. If you look on the left-hand side of my Visual Code UI, there is one bedrock_images_generation_demo. It's a Python Jupyter Notebook. We're going to be doing all of our work in this notebook. There's also a README file in this project. There's a requirements file. We'll be going over that in a moment. And then there's a contents folder, which will contain a number of folders by the time we're done. Most of all the work we're going to be doing is in the notebook, and then all of our content is going to go into the content folder. So that's all we really need to worry about. So let's get started. I mentioned 3 parts to the demo and to the notebook, so let me just recap those. We're going to start off in part 1 after we get through our prerequisites, and I'll talk about those in a moment. We're going to do text to image. So we're going to use a positive and a negative prompt to generate an image using Amazon Bedrock and Stable Diffusion XL, or SDXL 1.0 model. So we'll be calling the Amazon Bedrock API, specifically calling the SDXL 1.0 model, and generating an image from both a positive and a negative prompt. Then we'll move on to image. So in addition to a positive and negative prompt, we'll also be supplying an image to Amazon Bedrock. Instead of just sending text in our request body, we'll also be sending an image. And I have an existing image that we can use for the demonstration. You can also use your own images. We'll be using that image in both a positive and negative prompt to generate an image using the SDXL 1.0 model through Bedrock. Third, we'll be doing video to video. Now, the video to video is actually video to source frame to generated frame and then back to video. So we'll be taking a video, we'll be breaking it up into frames. We'll be running those frames through the Amazon Bedrock API to call Stable Diffusion. We'll be generating new frames, and then we'll stitch those frames back together. I mentioned the 2 technologies. So again, Amazon Bedrock, we're going to be calling all of that through an API call. This is a Python notebook, so we'll be using the AWS SDK for Python, or Boto 3, to make all of our API calls. And we'll be only be calling the SDXL 1.0 model today through Bedrock. So that's the only model that we'll be working with. Also have 2 references. The Amazon documentation, the AWS documentation for Amazon Bedrock is excellent. And there's a section for each model. There's over 20 models now available through Bedrock. There is a complete section just for SDXL 1.0. It goes over text to image and image to image, and it also has some sample code we'll be looking at. And then if you want a further explanation on any of the parameters, although the AWS documentation is very good, there's also a link in the documentation. I have it here to the Stability AI API documentation for the SDXL model. You can get some more information there. I mentioned prerequisites. We need to start with some prerequisites. Now, I've only run a few cells in this notebook. The first cell that you'll want to run is setting up your Python environment. So we'll be creating a virtual Python environment. So you want to go ahead and run this first cell. And what you'll end up with, if you're not familiar with a virtual environment, and you should see it appear in your project, and you can see mine here, it's called Bedrock-VENV. This is our virtual Python environment that we're going to be running our notebook in, and that's also going to be our kernel. So once we create our notebook, I'll show you how to select that as your kernel for your notebook. We need to select a kernel for the notebook. So you can go ahead and run that cell. I've already run it. The next cell we want to run is to install all of the Python packages, the requirements for this notebook, different packages we'll be using. And I'll go ahead and open that file. It's a pretty short list. There's only 5 packages. Obviously, Boto 3, we mentioned the Boto 3 Python SDK, Boto Core, which will help us if we get any errors. The other 2 technologies we're going to be using is FFmpeg and OpenCV, or Open Computer Vision. And the last one is pillow, which will help us manipulate images. Pretty short list of requirements. So go ahead and run that cell and you'll see those all install. I have the quiet flag and the upgrade flag. So if you already have installed, it should upgrade it. It should only take about a minute or two to install those. Once you've created your virtual environment, installed your packages, you want to select this as your kernel. With Jupyter Notebooks, we need to select a kernel. You can go up here if you're in Visual Studio Code, in the upper right-hand corner. I have Python 3.11.8. I would make sure you have a recent 3.x version of Python loaded. And then you should see the virtual environment here. So the Bedrock-VENV was what I named it in the notebook. And then go ahead and select that. So that's your kernel. You want to authenticate. Obviously, we're going to be calling the Amazon Bedrock API. If you're in Cloud9, if you're in Amazon SageMaker Studio, if you're on a Windows machine or a Linux machine, if you're on an EC2 instance, that process can be a little different. So make sure you authenticate at this point before you continue. Again, I've already authenticated. I am logged into AWS from my console. So locally through my terminal, I'm logged in this environment. So you want to go ahead and do that however you do that for the environment that you're in. A couple other things we need to do. I mentioned FFmpeg. We saw in the requirements that we're installing the FFmpeg Python package. That has a dependency though on FFmpeg being loaded locally. So since I'm on a Mac, I'm going to use Homebrew to install FFmpeg on my Mac. The installation requirements suggest running both update and upgrade. You definitely want to run update to make sure you get the latest package. The only challenge with upgrade, if you haven't upgraded your packages in a long time, instead of just installing FFmpeg, this might want to upgrade your packages. I have 50 to 100 packages, 20 or 30 of those might need an upgrade. That could run a long time. So if you don't want to upgrade all your packages now and maybe cause some additional problems, just go ahead and you can comment that out and then just run the update and then install FFmpeg. Now I know that all my packages are up to date, so I'm just going to run that cell. And that should only take a moment. Yeah, so everything's up to date. And that just took a minute. I already had FFmpeg installed. While I'm running this right now, 6.1.13 is the latest version of FFmpeg at the time that I'm doing this demonstration. So we've created a virtual environment. We've installed our packages. We've authenticated AWS. We've selected that kernel. We've installed FFmpeg. One last prerequisite before we get going. I mentioned the content folder. You can see the two folders here that are in white versus the four that are in gray on my screen. The source images and generated images, those are supplied with the GitHub project. I have a source image that we're going to be using for image to image, and I also have some examples of generated images. As you generate images with text to image or image to image, those are going to get dropped into this folder. So those are in there. The other four folders, I happen to have things in there because I've worked through this notebook a few times to make sure there's no bugs. You will not have these folders in gray, so you want to run the next command. And the good thing is, and I'll run the command myself, if you already have the folders, it'll just give you a message they already exist. If not, it'll generate them. And then I just list out the contents and you should see 6 folders. So we have the source images, the source frames, so delineating between frames of a video and images. They're the same thing really, just trying to separate those for the different sections. And then source videos. And we're going to be using the source videos. That's where we're going to put the videos we're going to be using. And you will need to download those videos yourself, but we'll get to that in that section. And then we have generated frames, generated images, and generated videos. As we generate from either text to image or image to image or video to video, those generated assets will appear in these folders. You should have the 6 folders here. And again, only 2 of those are included in the project. Once that's run successfully, we can start with our text to image. I mentioned that we're going to be using the Stable Diffusion SDXL 1.0 model. If you've used Bedrock before, you're probably familiar with model IDs. Every model in Amazon Bedrock has a model ID. Since we're going to be using that model ID throughout all 3 demonstrations, I'm going to set that constant right now, and we're just going to call that, whether we're doing text to image, image to image, or video to image, we're just going to be calling this. So you can go ahead and run that cell, and that'll just set that constant. The next thing that we have is the code for text to image. I mentioned code samples, and I have a link here, so let me jump over. This is the Amazon Bedrock documentation. You can see here I'm in Amazon Bedrock. And if we go into model inference parameters, so again, this is inference, right? It's machine learning, it's inference. The model's already been trained, it's hosted in Amazon Bedrock. We're going to be making a call to it. We're going to be passing in our request body, and we're going to get back our response, which in this case is going to be an image along with some metadata. You can see all the different models here. Here's Stability.ai Diffusion models, and specifically 1.0. That's the model we want to be using. And specifically, we're going to be looking at text to image, and then we're going to be doing image to image. The documentation goes into, and I'll show you in a moment, there's quite a bit of configuration. In addition to your text prompts, and you can have both positive and negative prompts, we need to give the width and height of the image, and then there's some additional parameters that we need to give. And each one of those parameters are explained here. So it talks a little bit about the prompt, some of the limitations, the CFG scale, what the min, max, and default values are. You can read through Also reading through the Stability.ai documentation is good to kind of really understand what these are and how by changing these numbers, you're really going to change the look of the images. We have the clip guidance scale. Again, some of these are optional. You don't need to use them, and you could comment them out in the code. If you're not sure what they are, you don't want to use them, just comment them out and the code will still run. The height is optional. The width is optional. I have mine set to 1024 by 1024 for text to image. And then as we get into the videos, obviously that will change. Sampler gives some different options here. Again, if you're not familiar with these, just Google these, look these up. I'm using the ones that I think are best for this demonstration. Shouldn't need to change a lot of this stuff. So if you're not familiar with a lot of these different parameters, you'll see these a lot with a lot of image models. The number of steps, usually 25 is or 25 to 30. 30 is the default here. You can go as low as 10 and as high as 50. You want to play around with steps. And then we have style presets, which is fairly unique, at least in this case, to XASL 1.0 model. Things like 3D, analog film, anime we're going to be using. Some pretty funny ones like modeling compound, origami. Most of the ones that we're going to be using in this are either anime or digital art or fantasy art. And then again, the code sample. So this is the code sample. This is in the notebook. I've modified it slightly just to improve it, made it a little more Pythonic in nature, able to pass in a few parameters, and also just fix there were some logging issues using it in a notebook. Again, we're doing text to image. We've set the model. This is all the code. I've included a number of prompts. We're going to be starting off and I'm going to be creating a mythical beast, a phoenix, if you're familiar with the phoenix bird. And then in image to image, I actually have a picture of a bird and we're going to transform that everyday kind of songbird into a phoenix. I have a positive prompt and a negative prompt. And I also have some references here. If you change the values and don't remember what the notebook was sent at, I have 5 different examples here. So we have the phoenix, have a samurai warrior, a cat conjuring goldfish, a robot, a little Pixar Batman as an example. You're free to create whatever you want. I just have some examples here, and we also have the example images. And I have both the positive and the negative prompt. I've mentioned some of the settings here just in case you change them and forget what they were. And then I also have the inspiration. So I didn't use the prompts exactly as they were. In some cases I did. I had to make a few modifications just to make it look right. The references are here. So if you want to know where the reference came from, for example, for the Phoenix, this is on Civid.ai. This is what I used as a reference. Our image will look nothing like this. This is a different model. Some of these use 2, 3, or 4 different fine-tuned models. They use LoRa's. Our image will not look like this. If you're familiar with Civid.ai and you see some just amazing images on here, keep in mind that these images were not created using just the SDXL base model. They're much more complex workflows that create these really stunning images. And that's not our goal today. It's really to learn how to use Amazon Bedrock through the API. It's not to create the most amazing images. There are ways to do that. Civid.ai is a great place to find some of those workflows and some of the people creating these images. But again, this was the inspiration for the prompt. We'll go ahead and run this. We set the model variable. We'll run this code. Now this code is just setting up 2 methods. Generate image, and that gets the model ID passed in, which is the constant in the body. This is the request body. And the first method is going to build that request body. So you can see here we have build request body. We're passing in the model ID, the positive and the negative prompt. I broke out the positive and the negative prompt as you saw up here as variables just to make it a little easier. You can just switch by, if you comment these out and uncomment these other ones, you can then use these other positive and negative prompts that I have here. So builds the request body. So you see here we have a JSON body. We have the positive prompt. You can play around with the weighting. The positive prompt is 1 or greater. And then if it's a negative number, that's treated as a negative prompt. So we have the negative prompt. We're just going to be generating 1024 by 1024 pixel images. That is the maximum image size for the SDXL 1.0 model. And then you can see some of the other settings here. So just doing some basic, we're using the fantasy art. This is our seed, 25 steps, and the CFG scale of 15. And this is our sampler that I've chosen. Again, you don't need to know what all these stand for. If you don't want to change anything, just play around with the seed and you can see how that changes the images. So I went ahead and ran that. And what it does is it actually just puts a timestamp on the image. If we go into generated images, we can see that we have a new image here. I'll explain these other sample images in a minute, but this is the image that it generated. And you can just keep running this. If I run this again, obviously I didn't change anything config, so I'll get an identical image, but it won't overwrite your first image. So if you're playing around with this and you just want to get some cool images, they'll get saved in this folder. And if we take a look, that was based on the prompts that you saw. That again looks nothing like the Civid.ai example. And those prompts have been modified slightly, but pretty cool. We got a Phoenix back in 25 steps, and that's the image that we generated. So we passed in a positive and a negative prompt, and then using text to image, using Amazon Bedrock with the correct API call for text to image, we called the SDXL 1.0 model and got this picture back of a Phoenix. There's also some additional examples here. Just changing things like the number of steps or the seeds can have dramatically different effects. So I think I have 4 different phoenixes here, and some of these are just changing the number of steps. The higher number of steps, the image can change dramatically from 20 to 25 to 30 or 50 steps at the maximum. If you're not great at writing prompts, just go on Prompt Hero or Stability.ai and find some prompts you like, and you can just kind of play around with them. That's what I did. This wasn't something I created from scratch. The other prompts that are available there, so there's a little Pixar Batman. If you run that, just change the settings. I have the settings there. These are not meant to be the best images in the world, just showing you what the SDXL 1.0 model is capable of. It's capable of generating much better images than the ones that I've created here quickly. Just changing the positive and the negative prompt, passing that into Amazon Bedrock and getting these images back. The samurai, the robot, the cat conjuring fish, and Batman, just some examples. And then there's 4 different examples of the phoenix that we created. So that's how we do text to image. So we ran that, and we can display that if we want. So that was the phoenix that we created. And this is where we're using pill, and then we're using the IPython with the display component to be able to display this image. And you can also resize it. So again, this image is actually 1024 by 1024. I'm just displaying them in the notebook a little smaller. There's also a link. So as we go through here for most of the examples, there's a link here too. And you can click on that and that'll open that image that's over here. We use text to image. We pass in a positive, negative prompt, and we generated an image. And then again, there's some other examples here you can play around with. So that's part 1. Let's move on to part 2, and this is where it gets exciting. So this is image to image. So let me run the first cell here, and I'll show you what we're going to start with. So I mentioned we're going to start with an image. You can upload as many images as you want, and I would encourage you, this might not be the most exciting image in the world. It works pretty good because of the theme of the phoenix that we used in text to image. I'm going to be applying those same prompts to this bird and see how we can transform this bird in different ways to look more like a phoenix. Again, maybe not the most exciting subject, so if you're not into birds, feel free to find a different image. And those are located, hold her up. Those are located in the source image. So you can see that we have the original image here. One thing obviously to be very careful of for both images and video, to make sure they're copyright free. I believe that most of the sources that I went to here for the videos are not included in the project. You can download them, but if you check, most of them are, especially for just educational purposes. You can download those and use those. Obviously, if those are videos you own, like I have one where it's a selfie of myself that I filmed on my phone, I obviously own that. There are a lot of videos and images available out there that you can run in this notebook. Just be careful of copyright. So that was the bird. This is the bird we're going to start with. So you remember what the phoenix looked like. So that's a phoenix. And this is our bird. And we're going to turn that into a phoenix. And we're going to do that through image to image. We have new code now. So the previous code example was text to image. This code is very similar, but this is going to be for image to image. And again, I've modified this. Now, this is modified quite a bit from the code, and they go through all of the different settings. There are a few more settings here. Some of them are similar. Some of them are new. You can take a look at that. It explains what each of the configurations are in the request body and how to use those. And again, many of these are optional. You don't need to use them. If I've used them in my code, you can just comment them out and the code will still run just fine. And then we have things like seed and step. Those are all the same. Your sampler is the same as the text image, the style presets, etc. Those are all similar. And then they have this code sample, and this is what I started with. And then in the notebook, I've just made it easier because we're going to be creating images and then we're going to be looping through frames of the video to generate frames. And I wanted to make this a lot easier to reuse this code. So did a few things. First thing was we have an image to image request object or class. And this allows us to pass in all the configuration. So I can just keep calling this. So imagine if we have 25, 50, 100 frames, I create this object once and then I just run through the frames and pass each frame or each image in each time. It just makes it a lot easier, and I'll show you how that works. I also did an enum for the style presets, only because I got tired of typing in fantasy art or digital art or comic book or modeling compound and just doing spelling errors. So I thought this was easier. Not required, but there is a styles preset enum class, and I'll show you how that works in a moment. So those are the two big changes. And then we have the same two classes. So generate image, we pass in the model ID, which is going to be the same I said for the whole notebook, and then the request body, which we'll build in the other method. Passes that in. Now the difference with this request body, we're also passing in the image along with the positive and optional negative prompts in order to generate a new image based on the original image plus the prompts. And then again, we have our build our request body. It should look pretty similar, right? We have our JSON body here, our positive and negative prompts. The only thing we're doing here is we're building up this image to image request. So I've instantiated an image to image request object. I've passed that in, and then I'm pulling those parameters out, and I'm going to pass those in through the body. If this doesn't make sense, just take a look at the code. The code is pretty straightforward. Code sample is very good, but if you're going to go into production with this, if you want to put a UI in front of it, a lot of these enhancements will help you, like the enum style, the enum class for the preset styles, or especially being able to pass in the image to image request will make it much easier, again, if you have a front end or a UI on top of this. So we pass those in. We do have some different options, and I didn't mention this the first one. We could generate JPEGs or PNG files for images. We can also change the amount of compression. I'm going with no compression. So for this demonstration, I'm going to create the highest quality JPEGs. The same with PNG files. If you're going to create PNG files, you can increase it, obviously, depending on how much disk space you have. So we have our base code ready to go. We run that cell. This is cell where we'll actually create our image. A couple things we need to define. Again, we're going to define our positive and our negative prompt, and you can play around with these. These are identical to the text to image prompts that I used above. I don't think there's any difference here. We want to call our source image. So what's the source image that we're going to pass into the image to image Bedrock API call? And then generated images, where do we want to put that image when it's done? So those are the 4 constants or variables that you'll want to set, and you can play around with those. You don't need to change those. You can just run this cell as is if you want to try it out. And then here's our image to image request body. I'm going to return a 1024 by 1024 pixel image. I have some notes here. So the resolution for SDXL 1.0 is roughly 1 million pixels, and that equates to 1024 by 1024. You can do any variation of that as long as you don't exceed these number of pixels. If you do, you'll get an error. The other thing to know is it needs to be a multiple of 64. That's critical in the videos because usually video formats aren't necessarily divisible by 64. So sometimes you got to shave a few pixels off to get it to fit or distort it a little bit. But we'll talk about that then. But just keep in mind that at least for the SDXL model on Amazon Bedrock, it is limited on Amazon Bedrock, at least currently, to 1024 by 1024. So we set that up 1024. Here's my positive and negative prompt. My image strength, I've set that to 0.4. Again, I would read up if you're not familiar with what this means. It's scale from 0 to 1, so 0.4. The CFG scale, again, from roughly 0 to 35, I believe. Again, I would read the documentation. The clip guidance preset, a lot of these are optional. If you don't want to use these, you can comment them out and the code will still run just fine. If you're not sure what they are, you want to just try the defaults, just comment those out. Again, pick the sampler. Some of the models you can generate multiple images, different versions with different seeds. The SDXL model is limited to 1, I believe. So that's 1. I have a seed, 25 steps, and we're going to go with fantasy art. And this is the enumerator that I mentioned. You can see here if I call the preset style presets enumerator, and then I can go ahead and I can get different. So you see the analog, film, anime. It's just easier than typing out fantasy art every time and getting that wrong. Let's say I'm a terrible speller, so that enum class works a little easier for me. So that was one of the enhancements. And then we simply just call that build request body that we saw above. We pass in the image to image request object, the source image, which is up here, and the generated images. And this should generate an image for us. So let's try that out. So we can see that running, generating it. Here's the Bedrock response success. So it worked. Successfully generated an image with the SDXL 1.0 model. I have a link here, hyperlink to that image. That image should be here in the generated images folder. So we see that right here, the 553 image, and then the finished successful. No errors here. So we were able to pass in a base image, which was that bird. We also passed in a positive and negative prompt, and hopefully we'll get an image that looks like the bird. In this case, I purposely set these so we're kind of halfway in between a phoenix and what the bird looks like. Let's take a look at that. So that's pretty cool. Actually, let's take a look. So that's the generated image that we generated. And if we come down here, I'm going to display both of those side by side. So here's the original bird. You can remember what the phoenix looked like, and I think I'm using the same seed. Let's assume that that's kind of, if I didn't pass in an image, we'd end up with something like that. But we did pass in an image. So for image to image, we're using this picture of this bird. And then we've changed some of the configuration. So I'm, kind of halfway in between maybe, a phoenix and this bird. And you can see that they're similar, right? So we have the bird here, it's on a stick. Same bird here, but looks more like a phoenix, right? This is not maybe the best example in the world. I'm sure you can come up with much better examples. This is a very simple example with the bird, but you can really see how you can transform an image with image to image. And again, we can just take a look at that bird. So pretty cool detail. That was only 25 steps. You can increase the steps, might give you a little more detail. It'll probably change the look and the feel of it a little bit. Some additional variations. So I have in the folder here, I mentioned additional variations. You can see those here, image to image 1 through 8. And I put some of those in here. So I just built a quick array of parameters and I just display those here in the notebook. if you're interested in like, how can I change these and get a different look and feel? I've never done this before. Take a look at some of these so you can see the image strength, 0.5, 0.3, 0.2, 0.1, anywhere up to 1.0. The CFG scale, you can see how that affects it. So 7, 10, 15, as high as 35. And then I've tried some different seeds and also different number of steps. Having more steps isn't necessarily better. 25 is usually pretty typical. You can go higher. You may or may not get the effects you want. And the last thing is the style preset. So these were done with anime, digital art. Some of these other ones were done with, I also believe, the fantasy art settings, just within the context of a Phoenix, since it's, it's fantasy art, anime, digital art. That's what I used. And then if we look down here, we can kind of see. So this is variation, a little more cartoony, kind of like what we ended up when we ran the cell above the image that we looked at. This one's maybe just a little more flat art cartoony. This one's pretty cool, I thought. So again, you can come up with a million different variations by just making very small changes. I just came up with a few that I kind of liked. Again, much more like the Phoenix. And the reason is because I'm down to 0.2. If I were closer to 1.0, it would look more like the image of the bird. In this case, since I've lowered it down to 0.2, it looks much more like the Phoenix and less like the bird. And then if we, again, go all the way down to 0.1, now we're getting back to kind of the image that we saw when we generated our Phoenix originally. And this looks very, very little like the bird. Maybe the pose is similar and it happens to be on a branch because I told it that. Composition is this way because of that image. So even though we don't necessarily see anything that reminds us maybe of that original bird that we started with, compositionally probably had an impact on the image. In this case, using a CFG scale of 5, a little more detail, a little more artistic maybe, you tend to get this vignetted look, flatter areas with slight vignetting as you go up to 35. So the CFG scale here really changing the look and the feel of between these two images. Same image strength, 0.1, the CFG scale there is what's making the difference. And then also using 50 steps, although that might not have had a huge impact on this. Less steps might probably be fairly similar. And then again, just a last variation. So halfway, 0.5, 15. So kind of a midpoint, 25, kind of halfway in between the two again. Just some pretty cool variations. To kind of recap, we started with text to image and we generated a Phoenix using a positive and negative prompt. Then we went on to image and we have this bird that we started with. We passed that in along with the positive and negative prompt to Amazon Bedrock to the XDXL model using some code that has been improved just for the sake of ease of use when we're going to go to video later on. It just makes it easier to call. So we passed in the image along with the prompts and we got back a particular variation of this bird that's supposed to look more like a Phoenix, which I think it does. And then just to finish up a couple different variations on that, they're all contained over here. So you can go ahead and open any of these images. They're all included in the project and take a look at these variations. So just seeing how changing the settings on image to image, and this would go for text to image also, you can change the look and the feel. So that's sections 1 and 2. So let's move on to generating video to video animation using Amazon Bedrock. I outlined the process here I mentioned earlier, but I'll just go over it again. So kind of a 6-step process. Obviously, first you need a video. The project doesn't include a video. I have some links to some videos you can download. My recommendation, it's actually the last example I'll show, the easiest way to get started is do a selfie with your phone. In a well-lit room, get the phone close to your face, so just shoulders up. Good lighting and a clear background. A white background or a single color background is easiest. And just do a short video. Move your head side to side, up and down, make a funny face, smile, frown, etc. That's probably going to give you the best results for this. This demonstration, again, is not how to generate the best videos. I'll talk about it in the end. There's much superior tools to generate video animations, and I'll talk about some of those tools at the end. This is not the best way to generate video animations. It does generate some pretty cool animations. Really, our objective today is learn how to use Amazon Bedrock with the Amazon Bedrock API and some of the capabilities of the SDXL model, not necessarily how to generate the best animated videos. I'll show you how to do that in the end and introduce you to some tools to do that. So for this process, it's basically the image to image process. Just we have a large number of images, right? Because it's a video, we have frames, and each one of those frames is an image, and we're going to be passing each one of those frames into Bedrock. Again, just to highlight the process at a high level, you need to select a video and copy that into the source videos directory. So we talked about that. That's one of the directories that we created. So in the source videos, I have a few here, right? I have my Selfie, and then I've downloaded some of the ones that I recommend, and we'll take a look at those in a moment. So those will end up in there. So the first thing you want to do is either download one of the videos that I recommend later on here. I have the reference to those, or I would really recommend getting a selfie of yourself. That's going to work best. The next thing we're going to do is split that video into individual frames or JPEG images using OpenCV. Then we're going to select a contiguous series of frames that we want to animate. You might get a video that has 100, 200, 500, 1,000 frames. That's a lot of calls to Bedrock, and odds are the most effective animated videos are just a few frames, 5 frames, 10 frames, maybe 25 to 50 frames. You want to look through those frames and find something you think will kind of be an effective animated GIF or animated video. And I'll show you some examples in a moment on Stability.ai of kind of the state of the art. They're not dramatic, long running videos. It's very short, a few seconds of movement. Sometimes those repeat or reverse, we'll talk about that. Again, we're going to split the video into frames, and then you can kind of look at the frames, roll through the frames, depending on what tools you have. Pick a contiguous series. Maybe it's frames 50 to 100 you want to start with. And then we're going to run those frames in step 4. We're going to use the image to image method. We're going to use the exact same code, so no more code. We're going to call that same code that we called in section 2, and we're going to use that image to image request body object, and we're just going to loop through each one of those frames. And then in step 5, we're going to review those frames. So we've generated, let's say, 25 or 50 frames. We'll review those frames. A large language model, although you would think, hey, this is a continuous video with very slight differences between frames, especially at something like 24 frames per second, there's very little difference. The challenge is a large language model like the SDXL 1.0 model can render one frame entirely different than the next frame, even though there's the most subtlest of differences between the two frames. Maybe your eye can't even detect the differences. That's just the nature of the large language model. There's ways to minimize that, but if you're expecting every frame to be identical with the only thing different being movement or motion in it, that's not what you're going to get. So you are going to get some jittery effects, but you can minimize that by kind of reviewing those generated frames, deleting a few here and there that look totally different. They don't follow the style. Maybe the eyes are screwed up. If every one of them, and I have an example, I'm wearing a black t-shirt, one of those showed up with a bright print on it. Even though there was no print on the shirt, that's just a large language model. That's how I interpret it. Deleted that frame. So deleting some of those frames will help you. You also might want to do some retouching on a couple of these I call out. I did some minor retouching, like a few of the frames had a fake artist signature. It wasn't a real artist signature, but you'll find that a lot in Stable, Diffusion, XL, and some other models, creating like a painting effect or a photography effect. And it thinks, oh, well, most photographs or pieces of art that I was trained on have a signature, so I'll throw a signature on. So I'll also remove those. And then finally, we'll recombine those using FFmpeg and turn those into a video. So again, select a video, split the video, find the contiguous set of frames that you want to animate or generate new frames from, pass each one of those frames into Bedrock, generate a new frame, and then recombine those frames into a new video. So we'll start with a sample video, the source video. So in this frame, source videos and generated videos, that's going to stay the same. So just another constant for that cell. I do have a video. I've downloaded a video and I'll show you what it looks like. Not, again, the most exciting video, although I also didn't want to be controversial. So I figured the red squirrel is a safe video to start with. Also shows you some of the challenges if you're trying to create very smooth animation. So this is the video we're going to be starting with. I have a reference to where you can find the red squirrel. Let me just jump into there for a moment. You can download it. You click on download, and I make a suggestion in there. Go for the smaller video, so the 1280 by 720, because again, remember there's roughly a 1,000,000 pixel limit, that 1024 by 1024. So if you multiply 1280 by 720, you got to stay under that roughly 1,000,000 pixels for SDXL. So you can download a large video, but then you're going to get big frames. There's ways around this. If your video's bigger than this, you can certainly scale it, or you can just scale the frames as they're generated too. So there's a lot of options, but this is the video we're going to be using. And again, I'm not going to be using the whole video. You can tell this one looks like it's about 12 seconds long. I'm just going to be using a 2 or 3 second snippet, and I'm going to be generating new frames from it. And then we'll be using some other techniques like reversing those frames so that you get a smooth continuous loop. So that's the red squirrel video that we're going to be using in the demonstration. And there is a link down here in this cell. So the first thing we want to do is split the cells, and I have a method to split the cells. So we can go ahead and run this cell, and it's not going to do anything. Again, it's just defining a method, the frame splitter. We pass in the source video, which is the location of the source video, and the source frames. And this is the location where we want the frames to go. So it'll take the source video, it'll split that up into frames, and it'll drop it into this folder. And again, if you remember our content, we have source frames. So the video you download, you'll put in this folder. I have some in here. And then when I go ahead and split them, it'll split it into folders. And I've numbered mine to like demo 1, 2, 3, 4 through 7, because I have 7 videos that I've used to build this demonstration. And then we'll talk about that in a moment. So again, you can go ahead and run this cell if you haven't. And then to actually split it, and I have 2 examples here. So video 1 is a red squirrel. Video 2, which is a great video and the results are pretty cool, is another example. I'll just show you the example here before I split it. is a very cool video. This I call him Happy Guy video. That's another video that I use here, and I have an animation of that guy along with a couple other videos. The other video that I'll just show you before we get started here is the, let's see here. Amazing dancer in the video that we're going to make from it. The video animation that we're going to make from this is really cool. This is a great video because it has a white background, and we'll talk about that in a moment and why that makes things a little easier for doing video animations than a very busy background. So this is a great video. There is a link in there to download that video also. So let me just split the red squirrel here. So you can see her source video. I have the source video, and then I'm going to drop those frames into demo 1. Now I already have the frames here, but we'll go ahead and run it. It's just going to overwrite those. So you can see that it got to the end, can't receive any more frames, stream end exiting. That's expected. It's not necessarily an error. And you can see that we generated 387 frames. So if I go out to my Finder here and let me go into source frames, and that was demo 1, and we can see here that we have, in fact, 387 frames. And let me just call up, I'll just call up, frame 5. Let's take a look down here, maybe a little more exciting. Yeah, so there's our squirrel, if you can see that on my screen. And if I go through these, you can kind of see, right? So you can see the animation depending on how fast I can scroll through these and how fast my machine can display them. You can kind of see that motion. This is where you would start taking a look for a segment that you like. So let's say, let me just jump back to the notebook here. I have a segment picked. So this is where we're going to generate the frames from the source. We have our image request body, but right here is our loop. So you can see here for the squirrel, I liked frames 160 through 200. We go back over here to our Finder, and I'll scroll down to 160. So as I was looking through this, and that's 40 frames, that's actually a lot of frames. It's probably more than you need. You could do 10, 15, 25 frames. Just look for something with some interesting. So in this case, he's eating, he dropped a little food there. And I think by the time you get up to 200, his hands have moved back up to his mouth. So not a ton of motion, but also demonstrates some of the challenges in the video like this, where there's a very active background both on the left and the right of the squirrel, and then the squirrel is moving, and some of the challenges when you have a more busy background. Again, I've picked a range of frames 160 to 200. I've created 387 frames, and then what I would suggest here is just start with a small number, and actually to test it, if you want to play with the different settings here, I would just go through frames 160 to 162. Just create 1 or 2, and if you're like, oh, I like that look and feel, let me now expand that range and let it keep running, and I'll start looking to see if I like the results. If you don't, all you got to do is stop the cell and change the settings and run it again. And then when you finally get the settings that you want, the number of steps, the style, the sampler I wouldn't worry so much about, but things like image strength, CFG scale are going to have the biggest impact, followed by the number of steps in the seed and the preset styles. If you want to make big changes, even small changes like going from 0.3 to 0.4 to 0.5 will generate dramatically different images. CFG scale will be 0 to 35. That'll have pretty big impact. You don't need a preset. If you want to try without the preset, you can just comment it out. It won't error out. Or try presets. So things like fantasy versus anime versus comic style. Those will have an effect as long as your image strength is not high. If you boost this up near 1.0, it's pretty much going to give you the original image, and things like setting the preset style is not going to have a big impact because you're asking it to pretty much mirror the original frame, generate an image that looks a lot like the original. As you lower this, other settings like the preset style will have more of an impact, and we'll see that. We go ahead and run this cell. Again, we've set the positive and negative prompt. We're starting very simple, right? Red squirrel in the style of Pixar animation. It couldn't get any simpler. This negative prompt is also pretty typical. I copied this. Oftentimes, and you find these on the internet, there's some fairly generic, now this isn't fine-tuned for a red squirrel necessarily, it's probably more for humans. Things like, watermarks, signatures, fused fingers, too many fingers, missing arms, malformed limbs. You can imagine all the things if you've worked with some of these large language models, low quality, pixelization, mutilization, odd croppings, those type of things. This is a pretty generic negative prompt, so we're going to be using that. You can find that anywhere on the internet. And then our positive prompt, compared to our image to image, if you remember, they're pretty complex prompts. There was a lot of prompt engineering involved. This couldn't get any simpler, and that's intentionally starting with that. Again, our source frame, so we're going to use the source frames that we ran above in demo 1C folder, and we're going to generate frames in a folder called 4C. I have a number of generated frames here, demo 1, 1A, 1B, 1C. You'll want to create this folder. So the other thing you'll want to do, so if we're going to be running demo 1, you'll want to create a folder in here to match your files. So again, I think this squirrel is 1C, probably 1C. Yeah, so let's just fix that there. So demo 1 and then 1C. You'll need to create these folders. So created these folders running that command, so the generated video, source frames, etc. If you run this, you'll get an error. It'll run, but nothing will get generated. That's because you haven't created a folder. For example, for this, for the source frames, you'll want to create a demo1 folder. And then for the generated frames, you'll want to create demo1 folder. So you'll need to create these folders on your own. I didn't include those in here. You could certainly add that to the notebook. My source frames are in demo1 for the red squirrel. And then I'm going to be generating a new video. I'm going to be generating frames, which will eventually become a video. I'm going to put those in a folder called 1C. So you can go ahead and run this. I've already run this, and for the sake of time, I won't rerun it. Each one of these will probably take, depending on your connection, the region that you're in, I'm going to say on an average of 10 seconds per frame. And again, I'm running these linearly. So 160, 161, 162. So you can do the math, maybe around 10 seconds a frame. It'll take a little while to run. I've run this frame, and if you run this frame, you'll get the exact same results. So for 160 through 200 for the red squirrel, if you've downloaded the red squirrel video, if we go under generated frames under 1C, you'll see the squirrel. Now this looks pretty much like the original video, but you'll notice it's drawn. So it's like an illustration of a squirrel. It doesn't look exactly like our squirrel. The background's different, the bark is different. And we'll see that in a video. It's kind of hard to see here. But what I wanted to show you is, so we've generated those frames, right? So I have 40 frames. So I think we said 160 through 200, so roughly 40 frames. We made 40 calls to Amazon Bedrock. We passed each frame in one at a time, and we generated a new frame. We generated an image, a generative AI image using image to image for each frame. And that's what's we're gonna then recombine into our video. The other thing that I did here, and for the squirrel, it's not probably a big problem, but for things like faces, or if you have eyes or hands, you're gonna find some frames that are objectionable. And there's none here. If depending on what section of the squirrel I ran or my settings, you can get some really odd results. Just delete those. That's not going to break anything, as long as you don't delete too many in a row, because then you'll get a very jumpy video. Go ahead and delete. So if there was something really objectionable in this frame, maybe there was a big signature here, or the background totally changed and I didn't want to retouch it, you can just go ahead and delete it. This is the point where you want to kind of go through these, and you can see here pretty good. You'll see things pop up. Go ahead and delete those, and then the remaining frames are what we'll create our video from. The next thing we want to do is recombine our frames. You remember that we had our generated frames in folder 1C. We want to create a video in the generated videos. So here's our generated video folder. Now I have a lot of generated videos here. I've done quite a few videos and a lot of testing. Your folder will be empty, obviously, until you generate a new video. So this will be your first video that you're going to generate. This uses FFmpeg. We tell it where the frames were. So again, that corresponds to right here, right? The generated frames, same parameter. Under generated frames, I created a folder demo1C because I already had obviously a 1A and a 1B. In this step, I'm telling it where to find those frames, and then I want to recombine it using FFmpeg into a video. The only settings that you can play around with, the frame rate. I've used a very low frame rate. A typical video is maybe 24 frames a second. I'm going as low as 9. And because it's more of a video animation, an animated GIF, it doesn't have to be smooth, and it's not going to be smooth. And you'll see when we put this video together that it's not smooth. You shouldn't expect it to be super smooth. There are ways to do that. Again, these are not the tools that you would use to do that. Again, we're just learning Amazon Bedrock. So I'm using a kind of a low frame rate, but then it can see some of the variations in the image. You can change this if you want. If you want to go to 12, if you want to go to 18, 24, totally up to you. We'll just run this for 9. I've already created this video. This is set up to overwrite though, so we can just overwrite that video. You can see that took 1.2 seconds. So it took those 40 frames, and then at a rate of 9 frames per second, it created an MP4 file, demo1C MP4, and it stitched those 40 frames back together. And if we go out here to generated videos, and here we have demo1C, and here's our squirrel. So I'm gonna open that up in QuickTime on my Mac. It comes in full frame. It looks a little blurry. I'd make it a little smaller here on the screen, and it'll make it look a little sharper too, maybe. Let me just turn on here also loop, so that's important. And there's ways to improve this. You might see a little jumpiness. So there's our first video-to-video generative AI animation that we created. I don't want to call it a video. I think it's much more reminiscent of an animated GIF. So we have our squirrel eating, again, 40 frames. The squirrel itself, the motion, the squirrel isn't bad. The bark changes a little bit. The background changes a little more. And you also see these anomalies popping up here in the corner right there. And then eventually, if you ran some of their frames, those turn into signatures. And ideally, and those aren't too many frames, I could retouch those out in Photoshop. Where the real problem is, and let me just make this a little bigger here, is his feet. So if I hold over here, I'm gonna get the bar. But if you look at his feet, I mean, they're changing every frame, right? He's going from a branch to it looks like a rock, different types of wood, a second tail appears there. And the reason I picked the squirrel is because, these are some of the challenges you're going to run into. If you just look at the squirrel, it's a little jittery, it's not bad. But when you add in two different backgrounds, the bark, the green stuff on the left side, the forest, and then his feet on the bottom, the large language model interprets each one of these frames very differently. So even though from a frame to frame, there's very little movement and very little change from frame to frame in the video, you can see how a large language model interprets that. A good example is just look at his feet in the video. They're changing dramatically from frame to frame, although there's very little difference in the frame. His feet have probably not moved, if at all. That's one of the challenges with doing video animation this way. But again, this is not about creating the best animated GIFs. It's just showing you some different ways to use the SDXL model through Bedrock. But all in all, pretty cool. So that's our first video. So let's jump back over to our notebook. We created that video. We can display that also here. I'm using the IPython display with importing video. Then I'm telling it where the generated video is. In this case, I'm making it smaller. So I'm just saying, 720 by 1280, I think was the full size. Just show me 1.5 size. So instead of doing the math, I just divide by 2. Controls, muted, autoplay. I'm also looping it. That's really the one, the autoplay and the loop. So when I run this cell, it just, it brings up the video, it starts playing it, and it will loop it. In this case, when it does loop it, you probably don't see the jump from the first frame to the last frame back to the first frame. Obviously, in other cases, let's say an object has moved from across the screen from left to right. If you loop that, suddenly that object that moved from left to right now reappears on the left, and that gives it that stuttering effect. The one thing you can do, this is a common technique with animated GIFs, is you have your original video, so that's that forward motion. And this is just a simple example, right? If I have 4 frames, frame 1, 2, 3, and 4, what you can do is you can then make a copy of that video. And with FFmpeg, there is a reverse command. I can make a reverse copy that goes 4, 3, 2, 1. There's 2 frames of the same. There's a slight pause. As long as your frame weight is high enough, your eye's probably not going to see this. There's ways around that, but I wouldn't worry about it. Going from frame 1 to 4 and then back down to 1. And that gives me a smooth motion. So if an object is moved from left to right across the screen, that object then moves from right to left back across the screen, and then it loops. So you'll get a much smoother motion. This doesn't work for everything. In some cases that may not work well, but for something like the squirrel and some of the examples I have here, using that technique can help. I won't run all the commands. I have the commands here. You could run it in Python. I have some shell commands here. So you can see I set up the generated frames, the generated video, the name of the video. We create the video here. So I created the video here using Python. You can also use shell. So this is how you create a video using FFmpeg Python package. You can also run it here, or you could run this in your terminal. If you run all these commands together, I've got some odd errors. And part of the problem is it creates the video and then it starts running in this case, it creates a copy of that video and reverses the frames. The IO is still going on for this command for some reason that hasn't completed properly. So I tend to run these commands one at a time in my terminal, but nonetheless, create the video, create a copy of the video in reverse, the underscore reversed MP4 version. Then you can concatenate those together. And the easiest way, this just writes a small text file. That's one of the ways that FFmpeg can work. There's some other ways, but they seemed a little problematic, at least on the Mac. This was the easiest. So I just echo the 2 files, the forward motion and the reverse motion, into this vidless text file. And then I use the FFmpeg concat command, and I concat those 2 videos back into a combined video. And if we look at that combined video, let me play that here. So this is demo 1C. The squirrel, it's not going to be obvious. Some other videos, it will be more obvious. The difference between this video, I think we said we had 40 frames. This video has 80 frames, 1 to 40, and then 40 back to 1. And then it loops. So it's a continuous loop. If the squirrel, let's say, had his hands to his mouth and put them down, and then when the video loop, they suddenly reappear at his mouth. In this case, it's smooth. So if they're down at the end of the video, they'll come back up in the reverse, and then the video starts over again. It doesn't fix things like the background, obviously, but the squirrel is working pretty good. Some other videos here, we have the man dancing. I'll just display the video. The results are pretty cool. One thing to keep in mind here, so that video we saw of the person dancing, it's the same person on a white background. You might think, well, if I say I want, let's say, an African-American male, Asian female, or a Caucasian male, I'm going to get a very consistent look and feel, right? But you can see by this case you don't. So I used anime, but you get a very different effect. And it's very hard, unless you go all the way up to 0.9 and you're pretty much reproducing the video, you're going to get the exact same effect. I think that's also pretty cool. If you look at this video, the fluid motion, the dancing motion, is replicated from the original source frames. The person's look and feel changes dramatically, and it's pretty cool. You can change that. You could get closer to the original video. This also shows you, which is amazing, is the large language model giving the exact same prompts and an image which is almost identical to the image before it, a frame, will interpret it totally differently. And it's very hard to get around that and create a very, at least with this technique, to create a video which uses, let's say, the exact same character in every frame as they dance across the screen. That's very difficult with this technique. A couple other examples you can run through. We have another video example here, and this is the happy guy, so you can see the video here running. This is the video of the guy, and again, I just took a small segment of that frame. It's also reversed, so he kind of crouches down and then he comes back up and then the video loops again. Pretty neat effect. The other thing this shows, he did have a print shirt on, and you can see how the print changes. Now, I used a high enough CFG value where it didn't dramatically change from the original setting, so I used 0.5 here. I could go a little higher. It kept the print, but it did change it, but it's still, like, the color values of the clothes kind of remain the same. I did do things like telling it, wavy brown hair and glasses, just to make sure that I didn't get frames that didn't have that. I did get some frames that were objectionable, so I just deleted those. I didn't have to do any retouching on these. You can see other things, though, like if you watch his watch in the lower right corner as he stands back up, you'll see the watch moving or coming off, the watch changes. There's ways around that, but those are the things that are going to be hard to overcome. So moving on to our last video here, this is a selfie that I did of myself, and that's probably the easiest way to get started. You can find some good videos, but obviously, if we look at the video here that's still playing, if you want to get a very smooth animation, it can be hard if there's a lot going on. Having a solid background helps. Being up closer to the subject helps. Having clothes that are a single color versus a pattern also helps. Not that the effect in that video isn't cool, but if you want a very smooth effect, having, let's say it's a person being up close, having it from, like, let's say the shoulders up, having that person on a white background, having a solid color shirt, like let's say a black shirt, will make a much smoother animation. So I created a couple selfie videos, and we're going to use that, and I'll show you some of the dramatically different effects you can get using the same video if you properly do that. We have the selfie video. Again, I haven't included mine, but you can download your own if you want. And then I have a few different prompts here. I'm going to start out with a younger person. I also have a prompt for an older person. You can turn these on and off as you want and try them out. Our source video, so I split my selfie video into frames. I then selected those frames, and I've run a small number of those frames. Here we're going from about 75 frames, which again is a lot of frames. I would suggest starting with a smaller number of frames. The only thing with this is, even though there are 75 frames, I probably deleted at least 10 or 12 frames that I didn't like. I wouldn't suggest starting maybe with 75 frames. Start with a smaller number, and then you can always expand that, especially if you're trying different settings. These are the settings that I used, and we'll take a look at the first video that I created with that selfie. This was using a video of myself. Now, I can guarantee you I look nothing like this older gentleman. Some things that help. I was wearing a black t-shirt, and the prompt also says in a black t-shirt. So not only was I wearing a solid black t-shirt, I also, in the positive prompt, and I'll show you that in a moment, called out that the person in the image should have a black t-shirt. I did have to delete a few frames that had more dramatic shifts in lighting. And also, and for whatever reason, again, this is just how the models are trained. If you look in this corner right here, there's some lines. I did have to retouch some of these frames. There were signatures. Now, if it was a real signature and that was really the artist style, maybe you want to keep it. In this case, every single signature was different, and they weren't really the artist. It just somehow it looked at this line and said, oh, I have some similar examples and they have a signature, and then it started doing different signatures. So in some cases, I just retouched those out where there was a signature, and then where there's some lines, I just left them there as an effect. But again, this is just me. I'm looking at the camera. I turn my head slightly. I turn my head back. I look up. I look down. And then I decided that this little section here would make a good little quick animated video or animated GIF. I selected those frames and then generated this video from it. And again, this is that prompt. So dignified older man, weather-worn features, deep wrinkles, thick graying beard, Sam Elliott style mustache, right? That big, thick cowboy mustache that you see quite often. So helping like that, right? If I just said mustache, in one frame, it might have a thin, handlebar mustache. In the next frame, it might have a black mustache. In the next frame, it might have more gray. In the next frame, it might be a big, huge, Sam Elliott style mustache. So I'm going to go with the mustache, but I want to be very specific in the type of mustache I want. You can see here too, like solid black shirt, plain black t-shirt, adding those things. And even though I'm wearing one, if I didn't have this, what would happen is the person that was generated the older gentleman would have a black shirt on, but a lot of them would have different prints on them or lettering and stuff. I wore a black t-shirt, and I also called this out here. Again, this is not about prompt engineering. There's plenty of experts out there on how to do this. There's plenty of examples, but wondering like, how did I get this effect? And then when I show you the next one, will be very different. So the other one, using the same negative prompt, I did very similar, right? Dignified younger man. I'm not sure quite what a dignified younger man looks like. Again, wavy, dark brown hair, bright blue eyes. Again, then I went with solid black t-shirt, all the same. So this is a real different. A dignified older man with well-worn features and deep wrinkles and graying hair. Let's go with a young guy. Using similar settings, and I have the settings listed here. We can take a look at that video. And we get a much different effect. Amazingly different effect. So this is the exact same video, maybe a little bit different segment, some different frames that I picked out. This is one where I'm smiling. This one, I'm just turning my head slightly. In this one, I'm keeping eye contact and I'm smiling and then I'm frowning. And this is also an example where I looped it. So I did the forward motion, the smile to a frown, and then I reversed it, frown to a smile, stuck those or concatenated those back together like we saw earlier with FFmpeg, and then repeated that. And that's the video that you see here. And then we have the autoplay loop. So pretty smooth. In my opinion, this is about as good as it gets. If you want a consistent character with similar, you can look at the black t-shirts not changing too much. The folds are changing. You're not going to get away from that. My hair is changing. I wish I had more hair. That's fairly accurate. Probably a little more hair, but you can see there's a little waviness in the hair, but it's staying pretty consistent. If you look at the ears, they're staying pretty stable. The biggest thing I notice is the nose, and you'll notice that too. The nose is changing, but it's not horrible. The lips are staying pretty consistent. The blue eyes are staying good, and I called out good eyes. That's one place you'll have a problem. You'll probably get some frames with really messed up eyes. Just delete those frames as long as it's not too many. If it's too many, adjust your settings and just regenerate the frames. But in my opinion, this is probably as good as you'll get for video animation, or call it an animated GIF. Even though it's an animated GIF, you could turn it into one. That's probably as good as you can expect. Solid background. I'm up close, wearing solid clothes. Again, a simple background, because the problem is if you're in a busy background like the squirrel's changing, but so is the background. Your eye doesn't know what to look at. At least here, even though there's some slight variation and waviness in my face, the background staying consistent, my shirt staying consistent, and the face is fairly consistent. Another selfie here, a little bit different. We can take a look at this. I think I use the modeling compound, which can get really crazy. It looks like clay, and that's kind of the idea here. I adjusted it a little bit so it wasn't crazy. Every one of these frames is different. There's very little consistency between these frames, other than it's an elderly gentleman. His mustache is pretty consistent. His hat's fairly consistent. His clothes are changing. The background's staying consistent. It's still a pretty cool little video. Again, I wasn't going for, an exact match and trying to get the exact same character from frame to frame, but you can get some pretty neat effects. It also shows you just how a large language model, I'll use the word thinks. Every one of those frames, there's very, very little difference from frame to frame. This was a selfie of myself. I don't look like that. I wasn't moving much, and you don't see a lot of movement here, but look how dramatically different each image is. And that's the large language model with the exact same prompts and the exact same configuration, how it can interpret very subtle differences, totally different. And that's where it's going to get very hard to get away from some of these changes. So you really just need to embrace it. If you're really looking to kind of do state-of-the-art generative AI animation right now, some suggestions, and all of these can also be run on AWS. You might think, I have to go out and use my local machine, that these aren't AWS services. And I use Amazon workspaces, GPU-based workspaces quite a bit. So you can run all of these tools on AWS. There's multiple ways to do that. You can download custom tuned models if you don't want to use Amazon Bedrock or the SDXL model or the new Titan image generation model. Maybe you want to use a base model with a fine-tuned model. You want to use a couple LoRa's. You want to use an upscaler model or refiner model. You can install all those on AWS. I use an Amazon Workspaces environment. But take a look at Automatic 1111 or A1111, the Stable Diffusion UI. The other very popular one is Comfy UI. One is a little more visual, one's more programmatic. They both do pretty much the same. Also take a look at these if you're wondering how some of these images are made and you're just like, hey, I gave it a prompt and I just can't make a similar image like the one that we saw in Civid.ai, and I'll show you some example videos in a minute. That's because those are very complex workflows. Those are multi-pass, image to image, prompt to image, upscaling, refiner models, custom tuned models. If you see an amazing image online that was generated, there was probably a fairly complex workflow behind that, including fine-tuned models or a number of fine-tuned models. So you're not doing anything wrong. This demonstration is not how to create the most amazing images, just showing you how easy it is to use Amazon Bedrock. But again, the kind of the state of the art right now is something called Animate Diff with ControlNet. So take a look at those. That's how a lot of these videos are generated. I'll show you some examples in a minute. And then there are plugins, like I list here, the Animate Diff and ControlNet plugins you can install in the A111 Stable Diffusion UI and use those. Also, almost all the images that you see like on Civid.ai and some of these other sites, they're using fine-tuned stable diffusion models or LoRa's. I have a link here to some of those on Civid.ai, and then a link here on Hugging Face has a LoRa, the Explorer, kind of cute name. They're kind of limited. I would look at Civid.ai. Civid.ai has some absolutely amazing images and videos, but there's also some highly objectionable content on there. So make sure you turn on your filter. I think if you're not logged in, you don't see that content. But if you do create an account on there, make sure you turn on your filter if you don't want to see that type of content. But it is a great resource, sites like Civid.ai. The nice thing with that is all the images, most of the images, and I use it, have the positive and negative prompt. They have the CFG scale. They have the seed, so you can recreate those images, and also the custom tuned models that they're using. And a lot of those are based on the SDXL model that we use, but they've been fine tuned. For example, with the LoRa's or a number of LoRa's you can use, you can get all those from Civid.ai and download those directly into either Comfy UI or A1111. So this demonstration was not about how to create the highest quality animations. If you're interested in that, you can still use the SDXL model, but you probably want to use fine-tuned models in some of these tools. So take a look. And I'll just finish. We'll just jump over here. This is an example, and I filter out obviously some of the objectionable videos. And this is just in this year, I believe. I filtered on just this year. These are kind of what I would consider state-of-the-art. I'll call them video animations. I don't think they're really videos. They're more animated videos. A lot of these are using that video to frame technique and then, running those through a model. But you can see how consistent they are. Now, in some cases, you can look at the third one here, it's intentionally not consistent. But if you look at other ones like Wonder Woman, which I think is just an amazing video on the skateboard here, probably one of my favorite, they're staying very consistent there. And that's by using some of these other tools, you'll get that. You probably won't get that using the SDXL base model and that video to frame to video technique, but it's a good way to learn how these things are done. Again, it's learning Amazon Bedrock, but if you want to create these type of videos, some of those other tools will help. So you can see here the Joker, I think that was one of the top ones from last year. Got kind of the Bruce Lee style video here. Again, 2 people in motion and keeping very consistent. So very impressive. Probably starting with a video and then going video to video, but using some of those more advanced tools and using ControlNet, right? So with ControlNet, it will follow the outline, the location of the hands, the arms, the legs, the torso, the head, and it's really using the location of the body and then applying a new image over the top of that. That's how a lot of these are done. So, but you can see some of the videos, very cool. The bug, the eyeballs, for example. Some of these are also an example, right, of they're kind of cycling, right? So forward and then reverse and then looping, and you get that effect. Again, the bird, like, look how consistent. Remember the images that we created in the Flickr. Look at this, you can kind of see the wind blowing here. So some of these might be text to video animation. This looks maybe more like text to video, not video to video. Other ones you can kind of tell that are video to video. Amazing. Another one of the real popular ones from last year. The same with the one on the far right here. So I won't go any farther here and risk showing some inappropriate videos, but you kind of get the idea. These are really what are kind of state of the art for video animation, not necessarily video, but what I would consider more, animated videos or generative AI video shorts. Thank you very much. Appreciate your time. I hope you learned something today.